All right, so 8.3 is about the product and quotient theorems, and they have to do with how you multiply and divide complex numbers when they're written in polar form. And it turns out to be really, really nice. It's one of the reasons why we like working with complex numbers in polar form. Because if they're written in polar form, then to multiply two complex numbers together, all you have to do is multiply their moduli and add their arguments, right? So R1 cis theta 1 times R2 cis theta 2 is R1 R2 cis theta 1 plus theta 2. So you multiply these numbers and add those numbers, and that's all there is to it. We're going to prove this. So let's do it. So R1 cis theta 1 times R2 cis theta 2. I'm going to write that in expanded form, right? So that's going to be R1 cosine theta 1 plus I sine theta 1. And I want to multiply that by R2 times cosine theta 2 plus I sine theta 2. Well, since we're just multiplying, we can pull out R1 times R2 out in front right away. We have R1, R2 times well, let's go ahead and FOIL this. So cosine theta 1 cosine theta 2 plus I times cosine theta 1 sine theta 2 plus I times sine theta 1 cosine theta 2 you can hear my kids arguing, and then plus I squared sine theta 1 sine theta 2. Whew. Hard to squeeze all of that in there. There you go. Okay, so there's that expanded product. And now I'm just going to do some clever regroupings, okay? So first of all, I'm going to collect the cosine theta 1, cosine theta 2 with this sine theta 1, sine theta 2 at the end. Remember that I squared is just -1, so I'm going to call this minus sine theta 1, sine theta 2. Okay, that gets rid of the first and the last terms. And then in the middle two terms, I'm going to go ahead and factor out that I. And I'm going to factor out the I, and I'm going to write this one first. So I'm going to call this plus I times sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. And you may recognize why I wanted to do that. If you didn't recognize why I wanted to do that, let me give you a little hint, right? This has to do with the various sum formulas and difference formulas that we talked about for sine and cosine back when we were looking at trig identities, right? So cosine alpha, cosine beta minus sine alpha, sine beta, that was the same thing as cosine of alpha plus beta, right? In this case, alpha is theta 1 and beta is theta 2. So we've got R1, R2 times cosine theta 1 plus theta 2 plus I times, well, let's think now. Sine alpha cosine beta plus cosine alpha sine beta. That was the same thing as sine of alpha plus beta. So this is going to be sine theta 1 plus theta 2. And there you have it, right? So writing this back in condensed form, we would say this is R1, R2, cis theta 1 plus theta 2. And that's all there is to it. So it's a pretty cool pretty cool thing that in order to multiply these two things, we just multiply their moduli and then add their arguments. So let me give you an example to show you kind of the difference between how we would do this in rectangular form versus how nice it is in polar form. So in rectangular form, if we had a couple of complex numbers like 1 plus I root 3 times negative 2 root 3 plus 2I, then in order to multiply these things together, we would FOIL, right? So we would say this is negative 2 root 3 plus 2I minus, well, 2 root 3 times root 3 is 6, right? So we say minus 6I, and then plus 2 root 3 times I squared. Okay, so then we get negative 2 root 3 minus 4I minus 2 root 3. And then combining our like terms, we have negative 4 root 3 minus 4I. Okay, so that's how we would multiply a couple of complex numbers in rectangular form. Now, in polar form, on the other hand, I'm not going to show you this, I'm not going to prove it to you, but 1 plus I root 3 in polar form would be 2 cis 60 degrees. And negative 2 root 3 plus 2I would be 4 cis 150 degrees. And to multiply those two things together, all we have to do is multiply their arguments. 2 times 4 is 8. Or sorry, multiply their moduli. 2 times 4 is 8. And then add their arguments. 60 degrees plus 150 degrees is 210 degrees. And that's all there is to it. Right? And then you're done. So it's a lot easier. You can verify that these two things are the same. It would be a good exercise for you to do to verify that, in fact, these things are equivalent. These things are equivalent, and then the products are also equivalent. But they should be the same. I keep having to shush my kids. They keep wanting to come in and out of this room. Anyway, okay, so that's an example that kind of demonstrates this fact, but it also shows you why this fact is so nice. We love multiplying things when they're in polar form. So let me give you just a couple examples of this besides what I just did. So let's multiply, and let's write our answers in rectangular form. So here I left my answer in polar form, but let's go ahead and practice rewriting that in rectangular form. So we'll multiply, and then we'll write the answer in rectangular form. And I'll let you work on this first one. So see if you can do 3 cis 45 times 2 cis 135. Okay, so I'll let you do that one. Okay, and here's my solution. So finding the product is simple, right? 3 times 2 is 6. 135 plus 45 would be 180, right? Well, that's kind of nice. And now to put that into rectangular form, we would call this 6 times cosine 180 plus I times sine 180. Cosine of 180 degrees would be negative 1. Sine of 180 degrees would be 0. So this is just negative 6. Okay. And that's that one. Okay, here's another one. Let's do 4 times cosine 30 degrees plus I sine 30 degrees times 5 times cosine 120 degrees plus I sine 120 degrees. Okay, so let you work on that one. I'm going to see if I can squeeze my answer here on the bottom of the page. Yeah, so give the video a pause, see if you can work that out. Okay, now here's my solution. Again, finding the product is easy. These are already written in expanded form. This is how you'll see them in the homework, so I thought it might be good for me to give you an example of this. But it works the same way, right? You multiply the moduli, and then you add the arguments. 30 plus 120 is 150. Now to put that into rectangular form, we just evaluate those trig values, right? So let me think. Cosine 150 degrees, that has reference angle of 30 degrees. Cosine of 30 degrees is root 3 over 2, but this would be in quadrant 2, right? So it's going to be negative root 3 over 2. So this is 20 times negative root 3 over 2. Sine of 150 degrees then would be 1/2, right? So plus 1/2 I. And then distributing the 20, we would have negative 10 root 3 plus 10I. And that's that, right? So that's how the product rule works. It's really pretty nice. The quotient rule is very similar to this. Okay, so here's what the quotient rule looks like. Okay, so the quotient rule says if you want to divide a couple of complex numbers in polar form, then all you have to do is divide their moduli and then subtract their arguments. So again, it's going to be very, very easy to do this. And if you think back to how we divide complex numbers in rectangular form, that's a little more involved, right? That requires us to multiply by the conjugate of the denominator and then simplify a bunch of stuff. But this is going to be really pretty easy. I'm not going to prove this one. The proof is similar to the proof of the product rule. So I'll leave that to you as an exercise if you want to give it a shot on your own. But this rule does work indeed. So let me just give you a few examples. So let's use the quotient rule to divide and then write the answer in rectangular form. Okay, so let's do 10 cis negative 60 degrees over 5 cis 150 degrees. Go ahead and give the video a pause and see if you can work that one out. Okay, so here's my solution. So I'm going to divide the moduli. 10 divided by 5 is 2. And then I'm going to subtract the arguments. Negative 60 minus 150 would be negative 210, right? Now, if we want to change that into rectangular form, we can write this in expanded form first of all. And then we can evaluate those trig values. So this is going to be 2 times, cosine of 210. Now what would this be? I guess 180, 210, it would put us here, but the reference angle is still going to be 30, right? So I guess it's the same as the previous problem, right? So cosine, because cosine 30 degrees would be root 3 over 2, so this is going to be negative root 3 over 2 plus I times 1/2. And then distributing the 2, we have negative root 3 plus I. Okay. So that's that one. I want to give you 2 more. So here's a second one. Again, pause the video, see if you can work this one out. Let's do 24 times cosine 150 plus I sine 150 divided by 2 times cosine 30 plus I times sine of 30. Okay, so give that a pause, see if you can do it. Okay, so here's my solution. 24 divided by 2 is 12. 150 divided by 30 is 120. And now if I want to change that to rectangular form, I just evaluate those trig values. Cosine 120, that would have a reference angle of 181. So that would have a reference angle of 60, wouldn't it? 60 degrees. Okay, cosine 60 degrees is 1/2, but since we're in quadrant 2, this is going to be negative 1/2. And plus root 3 over 2i. Then distribute the 12, and we get negative 6 plus 6 root 3i. Or actually, the way the book will write it, is they'll say negative 6 plus 6i root 3, which I don't really love. I like it this way better. I think it makes it more clear that, hey, this is a complex number. It's written in the form a plus bi. B in this case is 6 root 3. It's not quite as clear when you look at it like that. But anyway, so one more. Now, I just wanted to give you one more example. You'll have a couple homework problems kind of like this, but I just wanted to give you an example where we're starting with something written in rectangular form. And let's take this. Now you could multiply by the conjugate of the denominator and just work with this in rectangular form. But what I want to do is see if you can, first of all, write these numbers in polar form, and then use the quotient rule to do the division, and then convert the answer back into rectangular form. Okay? It's not necessarily an easier way to do the problem, but it's not more difficult either. And I just think it'll be a good exercise and good review of some of the stuff we've talked about so far with complex numbers in polar form. So give the video a pause, see if you can do that. Okay, so here's my solution. So first of all, 2i is going to be that number right there. So I know that the argument's going to be 90 degrees, and I know that the modulus is going to be 2. So 2i is just 2 cis 90 degrees. Negative 1 minus I root 3 is a little trickier, I suppose. Negative 1 minus I times square root of 3. Square root of 3 is somewhere between 1 and 2. So that would be that number right there. So the modulus is going to be the square root of x squared plus y squared. That's square root of 1 plus 3, which is 2, right? And then the reference angle, tangent of not the reference angle, the argument, right? Same thing really, but the reference angle is going to be y over x, so that's root 3. If tangent theta equals root 3, then that means theta is going to be tangent inverse of root 3, but we're going to have to adjust it because tangent of inverse of root 3 would put you up here in quadrant 1. And we don't want to be in quadrant 1, we want to be in quadrant 3. So we're going to add 180 degrees to that, so that we end up in the right location. Tangent inverse of root 3. This is going to be where sine is root 3 over 2. Sine is root 3 over 2 at 60 degrees, right? So this is going to be 60 degrees plus 180 degrees. 60 degrees plus 180 degrees is 240 degrees. Okay. So we know that 2i is 2 cis 90. We know that negative 1 minus I root 3 is really, so negative 1 minus I root 3 is really 2 cis 240. So with that scratch work kind of out of the way, we can go ahead and do the quotient now. So this all was kind of some scratch work. Now let's actually do the quotient. So the quotient here. So this is going to be 2 cis 90 degrees over 2 cis 240 degrees. Well, 2 divided by 2 is 1. 90 minus 240. Oh, what? 240 minus 90 is 150. So I guess this would be negative 150. Okay, so that's going to be cosine of negative 150 plus I times sine of negative 150. Cosine negative 150. Oh, goodness. Negative 150. That's going to be in quadrant 3, right? It's going to be a quadrant 3, and the reference angle is going to be 30 degrees. I guess we just love these reference angles of 30 degrees right now. But anyway, so cosine 30 degrees, like we've been saying, is root 3 over 2. Since we're in quadrant 3, cosine's negative there. This is going to be negative root 3 over 2. Sine of negative 150 would be 1/2, but, or sorry, sine of 30 degrees would be 1/2, but since we're in quadrant 3, that's going to be a negative 1/2, right? So actually, let me write this again. This is negative root 3 over 2 minus 1/2 I. And that's the final answer there. And that'll do it for our discussion of the product and quotient rules.